Hello everyone. Welcome back to my channel. Today we are going to learn one of the most important concepts in Linux, which is UMASK. I will explain you what is UMASK, how it controls the default file and directory permissions, and also we will do live hands-on examples to fully understand how it works. After that, I will also show you how to make these UMASK settings permanent so that they stay even after a reboot. So let's get started. So the umask is a user file creation mode mask is a default permission mask which determines the default file and directory permissions when a user creates new file or directory in Linux. So in Linux, the default umask is 0022. 022 is actual a umask and the starting 0 is a special permission bit. So let's check the default umask. Here I have successfully launched and configured the EC2 instance and connected via SSH. After taking the root user access, I will run the command umask. Hence, the default umask is 022. After that, in Linux, the file and directory permissions are represented by the numbers, and each type of permission has its own value. For read, it's 4, which is R, and for write, which is represented by W, is 2, and for execute, which is X, is 1. Also, the file and directory permissions are split into three sections. That is, the first digit is for user, second digit is for group, and third digit is for others. So after that, whenever we create a file or directory, Linux applies the default permissions. Default for file is 666. As you can see, 4 plus 2 is 6. So read and write for all. And for a directory, the default permission is 777, which means read, write and execute, which is 4 plus 2 plus 1 is 7 for all. But that would be too open and insecure. So the umask subtract the permissions for from those defaults to determine the final permissions. So here the default umask is 022. We have to subtract it from 666. 6 minus 2 is 4, 6 minus 2 is 4, and 6 minus 0 is 6. So the file permission would be 644. So the 6 is for user, and the next 4 is for group, and the last 4 is for others. After that, 6 means 4 plus 2, which is read and write. So for file, user has a permission of read and write and no execute permission. So I am giving dash. For group, it's only 4, which means read, and for other, it is also 4, which means only read permission. So let's cross verify this by creating a file. As the default subnet is 022, I am going to create a file using the echo command and just giving the random data for the file. After that, we have to give the name of the file, file1.txt. Now we will list the created files using the ls, which is used to list. L is for long format, R is for reverse, and T is for sorted by time, and H is human readable format. File1.txt is created here. Now we will cross verify the permissions. For user, it is read, write and no execute permission, and here also for a user, read, write, no execute permission. After that, group has only read permission, which is also correct, and for other, it is also only read permission. This is about the file. So now let's check for the directory. We have to subtract the default subnet, which is 022. So here 7 minus 2 is 5, 7 minus 2 is 5, and 7 minus 0 is 7. So for the directory, the permission is 755. So as we all know, the left first digit is for user, which is 7, which means 4 plus 2 plus 1 is 7, which means the user has the read, write and execute permission for directory. After that, 5. 5 means 4 plus 1, which is read and execute. The first is read, no write, then execute. For other, it is 5, which means also read and execute. Now let's create one directory and verify this. We will first check the umask, which is default 022. Now let's create one directory using mkdir command, and we have to give the name of the directory. Here the directory is created. We will list it. So the directory is in blue color, and you can see the D stands for directory, and after that read write execute is for user, and here it is also read write and execute. Then read and execute is for group, it is also correct. Then last, which is read and execute for other, and also it is correct. I am going to copy this as it required for the further explanation. So after the default UMASK, we can set the UMASK manually for the various purposes. So UMASK 002 is used for the collaborative groups. So this UMASK is ideal when the multiple users belong to a same group and need to edit the shared files or folders. First, let's set this UMASK manually using the command UMASK. I am setting it for collaborative groups, which is 002. Now we will see the UMASK, and 002 is set up here. After that, we have to subtract 002 from 666. So 6 minus 2 is 4, and 6 minus 0 is 6, and 6. So it would be 664. Now let me copy this. After that, 6. 6 means 4 plus 2, which is read and write, no execute permission. Then for group, it is 6, which means 4 plus 2 and no execute permission. And for other, it is only read permission, as it is used for only collaborative groups. So the other just have the permission of read. As we have set up the UMask 002, we will create a file here. Giving the file name as file2.txt. Now we'll list it. So here the user has the permission of read, write and no execute permission. And group has the also permission of read, write and no execute. And other can only read, so it have only read permission. Now it is the time for directory, which is 777 minus 002. It would be 7 minus 2 is 577. So for user it is 7. 7 means read plus write plus execute, which is 4 plus 2 plus 1 is 7. And for group it is also 7, which is read, write and execute. And for other it is 5, which means read plus execute. Now let's create a directory and check, as the UMask is 002. So I'm going to create a directory using the command mkdir, and name of the directory is second. Now we'll list it. Here the directory is created with the name second, and the D, which stands for directory. Read, write, execute, which is for user. And the next is read, write, execute, which is for group. It is also correct. And the last is read and execute, which is for other. So let's move to the next UMask, which is 027. This is used when you want a more restrictive setup where the others get no permission at all, and the files should be only accessible by the owner and the group. So here we have to follow the same steps, as we have to subtract the UMask from the file permission, which is 666. So here 6 minus 7 is 0. There is no concept of borrowing here, as like maths. If the UMask digit is greater than the default permission digit, then we just go with the 0. Then 6 minus 2 is 4, and 6 minus 0 is 6. So it is 640 for file. So 6 is for user, which is read and write. 4 is for group, which is read only. And 0 for other, which means no permission. Now let's check it by creating the file. First we have to set the UMask 027. We have set up it. Now let's create a file. File3.txt has been created. Now we will check the permissions. For user it is read and write. For group it is read only, and for others there is no permission for other. After that, for directory 777 minus 027, so it would be 750 for directory. 7 means read, write and execute, which is 4 plus 2 plus 1, and 5 means 4 plus 1, which is read and execute, and 0 means no permission for other. So as the UMASK is 0 to 7, creating one directory. So here for user it is read, write and execute, and for group it is read and execute and no permission for other. So the next UMASK we can set is 077, which is the most restrictive setting. Only the owner of the file or directory will have the permissions, and the group and other get no access at all. So let's set up this using the UMASK 077. So for file 666 minus 077. So 00 and 6. So it is 600. For user it's 6 means read and write, no execute, and 00 for group and other, as it is highly restrictive, only the owner has the access. So here I have created one file last.txt. We will check the permission of this file. For user it is read and write, and for group and other there is no permission. For directory 777 minus 077, which would be 700. So 7 is for user, which means user has the full access of read, write and execute, and 0 for group and 0 for other, which means no permission. Let's create one directory and test this also. So here read, write and execute permission is for user only, and no permission for group and other. So here we have seen how to set the different UMASK values for different situations. But here is something important. All these changes are temporary. They only apply to the current terminal sessions. If you close the terminal or reboot the system, the UMASK will go back to its default value, which is 0022. As you can see here. So to make the UMASK setting permanent, the first file we will edit is etc profile. Here we have to add the UMASK value. I am just giving 027. This file is used for system-wide settings, and it runs automatically for all the users when they log in. Then we have to reboot the system to verify. So we are at EC2 user. UMASK value is set by default as 0 to 7, and after taking the root user access, it is also 0 to 7. Now the second file we will edit is etc bashrc. This is used for non-login interactive shells. I am editing it using the VI editor. You can add the UMASK anywhere in the file. Press I to insert, then enter UMASK. I am just giving 002. After 7 exit, we will reboot the system. So this makes sure that the UMASK is applied for all the bash users, and the new UMASK will now apply every time someone open a terminal. You can also verify this by just closing this terminal and again open the terminal and check the UMASK. So as we have seen, there are various ways to set the UMASK permanently in Linux. We have already covered the two important ones. For the system-wide login session, we use the etc profile, and we use the etc bashrc for non-login interactive shells. But there are other files as well which you can try on your own depending on your use case. So the next is for user-specific UMASK. You can edit tilde forward slash dot bashrc, which is for non-login shells, and the second one is the tilde forward slash dot bash underscore profile for the login shells. Just add your UMASK value at the bottom of these lines. And now for services like Apache, you can set the UMask through the systemd override files using the vi /etc then /systemd system httpd.service.d override.conf. In that you have to insert first in square bracket service, s is capital, and below that umask is equal to, then you have to give the value. Don't worry, I will also provide these commands in the comment section. So the last one is for login related umask, which is you have to edit using the vi then space etc login.devs. This affects the UMask settings applied by system tools like user add, login, and switch user. So in VI editor, you have to look for a line of UMask and update it. So that's all about UMask in Linux. I hope this video helped you understand the UMask more clearly, both in theory and practice. And if you have any questions or suggestions, feel free to drop them in the comment below. And I would love to hear from you. Thanks for watching. I will see you in the next video.